everybody. I'm here with Dave Ratt at the Ratt Sound headquarters in Camarillo, California. Thank you so much for inviting us in. This is your office. Pretty much what I expected, some cool stuff all around. Do you want to tell us about some of it?
I'm into sound, all kinds of sound, just sound, how it's evolved. So I have some thing that reproduces sound or recreates sound from every decade since the late 1800s. And here's some of them. I've got a wire recorder from the 40s, 50s, this Telefunken radios, pretty cool, it still works. This I got from a guy, his parents listened to War of the World, you know, that whole like aliens are coming, right? And this was the radio they had in the living room with the speaker.
I also saw you had these like micro
Oh,
wedges.
Pico wedges, yeah. These are little 3D prints I did on the printer over there, the resin printer of the wedges. Building like a little desktop PA system, desktop monitor rig where you could have multiple mixes on your desk or something cool to do, right? You set up your mixes, everything's on digital now, right? You set up all your mixes. If you had a little 8 mix, you could put up your little monitor rig. And
that's what I always love about your channel is it's like a mad scientist at work. You know, you're not just going to explain how things work, but you're going to set up small demonstrations. I'm excited to see what you have for us.
That's fun. Yeah, well, thank you. I appreciate that. I mean, for me, it's just like toys. Just make toys and play with stuff and figure it out.
Yeah. Well, let's go check it out.
All right, cool. So we'll kind of go through this backwards-ish. Up here, the bay doors. We've got 4 of these taped off areas where we've marked how big a semi is. So we can lay out the various trucks. We have multiple trucks.
So like rather than trying to figure out how the cases fit into the truck while you're loading.
Once you've done it, you can pre-rig it, and you can lay you can lay 2 trucks out. So we got rigging over here. This is air support. So hanging all the stuff off the ceilings. And then all the bars that tie into the motors. And we're in speaker world as well. This is where they clean and paint and upgrade all the speakers or do maintenance. Everything gets tested and swept after each show to make sure it's all functioning properly. There's some power. We got some DMV. We're mainly an L Acoustics house, but we've got DMV and we've got a lot of power soft stuff, different amps for different speakers. We got micro wedges and they're in there, some legacy things here, older breakout panels. So there's Mic World, bins and bins of mics. These are the old Rat subs. This is the oldest box in our inventory. These are Rat subs I built in 1988, the very first ones. The ones without the fly track are circa 88, maybe 87, 86. Some of these still go out. Pro Jam still uses them, and occasionally they will go out. Cool, that's about it. Should we go down to R&D area?
Sure. This must be the experimentation lab over here.
Yeah, this is R&D, where I work on my various projects that need to be done, fix things, pretty much problem solving.
And what is this project?
What exactly? Oh, you're talking about this.
Oh, yeah. What do we have going on here?
Well, this is the Relaxation chair. And it's for a kind of a Zen feeling that we can get by sitting in the middle. It consists of 6 super subs. They're 10,000 watts a piece with 30-inch cones driven by linear drive M-Force motors. 2 in the back, 1 on each side, 2 in the front. And then we've got these super wedges. These are quad amp, double 12, 10, 2-inch, all 4-inch diaphragms on the mids and highs, individually powered. And each one is powered by half of an X8, so about 5. The amp has a capability of about 5,000 watts per channel. So theoretically, it's a 40,000 watt amp powering those 2. Rear, left, and right, we've got some micro wedge 12s. They're on channels of an X4, another 5,000 watts per channel. Not driving that because it's 4 ohms. It could drive, but rear, left, right, and then top and bottom sub. And then underneath here, this is kind of cool. We've got a center speaker, which is a micro wedge 15, and these plates that this chair is on are actually PowerSoft movers. So these vibrate in stereo, left to right. And then this has got another M-Force motor on it, one of the same things that's driving those. So I think total power is maybe 60,000 plus another 60, probably 120,000 or so.
I'm assuming you've done some testing. It's safe for humans to be inside there.
Yeah.
All right.
Yeah.
I trust you, Dave.
It's safe.
Before we get there, could you show us how the signal's being routed, though?
Yeah. We can take a look at that. Right now, we just got it hooked up to a laptop, HDMI out, going to this 5.1 extractor that's taking the audio out, and then that feeds into a screen with the HDMI. And the audio signals feed into this X32, where we've got left, right, center, and then rear left, rear right, and then the various subs. There's a subwoofer left, subwoofer right, another sub left, side left, side right, rear center, and then plate left, plate right, vibrating throne. So, and that can all be matrix. You can send anything to anywhere.
You ready?
I'm ready.
3, 2. So it's amazing that discrete signals are being sent to all of these. Can we pull everything down but just the subs?
Yeah.
Because when there were explosions, I felt a gust of wind come from behind me. Oh, man.
Rear left, rear right. Plus center.
Wow.
So you can feel it.
That's intense. Yeah, that's incredible. What I didn't realize, what it really points out is these mixes for film, there's a lot of sub coming from like John Wick's pistol. You know what I mean?
Right. Well, we're over subbing it too, yeah.
Sure, but the mix is there, and that 0.1 channel you're coming into the console includes a lot of low end for things you wouldn't necessarily expect.
And these subs here, this is tied into the right speaker, right sub, left speaker, left sub. This is right and left. So the only thing that's on the 0.1 or the point whatever would be the two behind and the chair. So those are the points. Everything else is picked off. At this point, we can re-sign it however we want.
You mentioned that this motor on the Thumper is the same that's in these subs. Would you be able to tell us more about that?
Yeah, so check it out.
So this is one of the Super Sub 30s that we just heard. And you were telling me earlier that they operate on a different principle than a normal speaker might.
Well, you have a magnet. Speakers will have a magnet, usually a round magnet, and then you have a coil of wire. You can see this is a horn diaphragm. And when you have electricity or current flowing through a coil of wire that's immersed in a magnetic field, it will want to move in one direction or the other. In fact, you can give that a shot. Why don't you give that a try there?
Oh, I see. Oh man, it's a strong magnet. So then this is a DC source, so it's either, if I have it one direction, it's pulling in, the other direction it's gonna push out?
Yeah, I mean, with music, it would alternately push and pull, and then we'd hear what's going on. This is an EVX 180. We used to use those in the old rat subs. So there's typically two things. You have your surround, which keeps the edge of the cone straight. And then you have your spider, which is this guy down here. We'll see that in a second. And your spider keeps the voice coil straight. Together, the two support systems keep the voice coil centered in the gap. All right, so there we go. There's our coil of wire here. This is an aluminum flat wound, I can tell by looking at it. They make it sometimes copper, it's heavier, but they'll sound different. And it's wound on a former. And flat wound means it's a flat wire that's wound on edge instead of just using round wire. And then there's our gap, similar to this guy here.
This is both magnetic, is that right?
No, the magnet is this guy right underneath. So the magnetic circuit is one side of the magnet, the North Pole, let's say, comes up, hits this plate, and then that energy shows up here. The other side of the magnet touches this cup, and it transfers the magnetic energy through the metal all the way around onto a ring that sits here, and then brings the magnetic field. So you have a gap. So you have the two sides of the magnet are right on either side of this ring, and that's what we see here.
So it's like a moving coil microphone in reverse. If you have a moving coil microphone, there's a coil of wire around a magnet, and when you cause motion to the coil of wire, in proportion or in relation to that magnet, it'll create electrical current.
Right. This is exactly correct. And then and the reverse happens. It's reciprocal. So we can show that as well. So here's a speaker, and this will generate electricity when we move it. I'm going to take it off. See how it's making, you can feel the energy kind of, so it's creating electricity, and we're shorting it out, and we're hearing kind of the noise remnants of that happening.
And you can do the same thing here, right? If you, maybe you don't want to do it for too long to heat up or anything, but if I hold this here, it pulls in. Actually, is that pushing or pulling?
That's pulling.
That's pulling. But if I switch the polarity of the source, it's going to push out.
And you can do that on the big one too.
Oh, nice. So here's pushing out, pulling in. And I guess if you put this on a drill bit and spun it really quickly, it'd be positive, negative, positive, negative.
Yeah, you get square waves.
Kind of what we are dealing with the audio, not square waves, but alternating current, which results in a push and a pull. So how is this different from what we have going on here in the Super Sub?
Okay, so let's grab our wire. All right, so this is a linear drive motor. It's called an M-Force, and it was designed by Claudio over at PowerSoft. And this has instead of having a coil of wire immersed in a magnetic field attached to a cone, it's got a flat paddle with 4 magnets on it, and then these 2 huge slugs of coils of wire. It's actually wire wound like a flat wire round and round, immersed in and potted into a solid entity in these side plates. And this paddle is between those 2 steel immersed coils of wire. And what happens is, instead of it being round, you've got this huge paddle, and it's a moving magnet. Normally the coil moves. And one of the challenges with moving coils is you have to attach electricity to the coil. It means you got these flexible wires attached to it. If you make the wires too strong, they're heavy and they break. If you make them too thin, they lose a lot of energy and get hot. So you have a lead wire conundrum. This has got a moving magnet. So the coils of wire are fixed into this huge slug. So the paddle is attached to, the 4 magnets are on this paddle, and it's a fiberglass form, and it's attached to this bolt. And this bolt, we actually screw onto this high-density polyethylene cone. It's like what trash cans are made of, super strong stuff. And it just is bolted on, and it can move this. This thing is so strong, it'll break your finger. You hold a stiff finger to this thing moving at full power. I mean, you saw what it did with that drum seat. It'll take your whole body and fling it. So these things are quite powerful, a little bit dangerous, and very fun. So these are what's in the Super Sub. Now what I'm doing is I'm modifying these from, I'm adding this bottom frame on here, which has another spider on it. Here's the cones. So these are the old cones, and it was attached here, and it's a standard cone with a bolt in the middle. And what I'm doing is I'm upgrading them to these that have the same attachment point, but it's also got this secondary spider mounted here that gives it more alignment. So what was happening with these ones is when it was being driven hard, one side of this was getting hotter than the other, it was becoming softer, and the cone was rocking, and that was putting stress on the motor and on the cone and causing premature failure. So now with this second spider, you can't move this side. It moved this way, but it can't move side to side. So it forces it to stay aligned onto that motor shaft. So it should increase its long-term power handling and allow me to turn it up a little louder.
So once the speaker is inside the cabinet, we put this, which has
Yeah.
the amp mounted on the back.
Yeah, let's flip it over and we can look at the amp from
Okay.
that side of it. So, yep, watch your fingers.
Yep.
So the amp is encased in this sealed shell. This is acoustically or fully watertight, airtight. And then there's a connection for the speaker here and a connection for the pressure sensor. This will nestle in and bolt with a bunch of screws. There's a pressure sensor down in here that has a tube, an air tube that attaches to it, and it's got two outlets. This is a little hole on one side that can detect the pressure inside the back of the chamber here. And then there's a 1/4-inch tube that goes through the edge of the cone out to the front and detects the pressure in the front of the cone. And it looks for a differential. If the cone was to crack, or for some reason those pressure differentials are not similar, right? Equal and opposite, it can shut down the motor and put it into protect. You have control over those parameters. So if the motor fails, you're not sitting there running all this juice and creating a fire or something. So it's actually it tells us things are going on. You can actually go farther and have it measure the pressure and set it for linearity and alter the signal that it's sending to the motor to make sure that it's following a linear excursion, but I don't do that. I just use it for protection.
In all of these, why use this special design rather than the more typical moving coil design?
That's a great question. A typical speaker does not have the ability to really go much. It's very difficult to get a cone speaker to go below 28, 25 cycles. These are tuned at 23.5 cycles, and they can tune lower. This thing, you can run power into that motor, and it'll move. It's full motion, extremely slow. You can't get a normal speaker to do that because of the inductance and it just isn't, the heat dissipation. This coil on a normal speaker, that coil is sitting in air, right? And then there's a magnetic field around it. In this, the coil is embedded in a steel iron block. So its ability to dissipate massive amounts of heat, order of magnitude more than a normal speaker would be able to do. If we take this, what we'll do is I have a function generator on here. Okay, so this is frequency, that's 20 hertz. Now we got some, that's 31, 25 hertz. That's 23. Come feel this.
Really cool.
Yeah.
Wow. Well, thank you, Dave, for showing us around. If you haven't seen Dave's YouTube channel, use the link in the description below to check out some of his videos. We'll see you next time.